I got 2 minutes. Okay, and we're just gonna give a little bit of time here to make sure everybody can get settled in. So Robin, I really enjoyed your slideshow, and we're gonna be waiting for Luis Ramos to come and start this next session. Some of mine is gonna maybe touch on some of yours. Anybody who's still around, please stick around. We've got lots of good sessions coming. I guess they're gonna be nonstop. But we got some interesting stuff coming on.
Your session should be as a transition from mine as per the questions that we had actually on the cloud applications and so on, actually.
There's no stopping in the Mons, right? So that's what we're trying to do here. Just a pit stop in between sessions.
Yep, Bill, I'm here. So I think we're just about ready to start. It's 6 over here on this side. So I'll be moderating, taking over from Amilcar for this session and the next as well. Bill Rice will be your speaker and presenter for this next session. And we'll hold off all the QA till the end. You can make your questions during the presentation. I'll take note of them and take 5-10 minutes at the end to go through them with Bill. All right, let's go.
All right, yeah, so thank you so much for joining this session. Again, just a little bit about me. I'm a senior solutions architect with Ateme. I work primarily on the pre-sale side in North America. And we're gonna talk about different deliveries on how you can leverage Ateme solutions in either an on-premise or off-premise cloud. We're also gonna do a couple live demos. I'm hoping we have enough time. We're gonna be showing some pain points maybe of an existing system. We're gonna take a quick little demo of a live StatMux headend in the cloud. It's a very simple like headend in the cloud demo we're running in Amazon currently in AWS. And then we're going to do a little CMAF demo. Earlier in the day, we did this session already, and they broke it into 2 sessions, 2 30-minute sessions, but I'm gonna run through it all myself. But I think it's gonna be a good session. So whenever you talk about on-prem and off-prem cloud, a lot of people may or may not have some problems. Problems like, how do you get to newer technology, maybe without a forklift upgrade? How do you create new channels? Maybe some of your infrastructure is no longer capable to add new channels. Maybe you've got some hardware limitations that's not allowing you to get to new codecs. Maybe you're not allowed to add new features such as HDR. Maybe you're not allowed, maybe you can't add some new audio codecs. We've got discussions going on for Dolby AC4, MPEG-H, Dolby Atmos, SDR to HDR up conversion, and SD to HD, HD to 4K up conversions. Maybe your infrastructure is limited. Then another problem people run into is maintaining disaster recovery in an on-premise location. They have to maintain 2 geo-redundant sites, and they need to make sure that equipment is running on both of those sites. And part of that infrastructure problem is we are, if you want to serve modern audiences, right? You have people viewing from TVs, people viewing from iPhones, from iPads. How are you able to launch those channels, feed them the content they need, feed them the quality that they expect, and how do you do pop-up channels? We have coronavirus, for example, just hit us unexpectedly in North America this year. Maybe you want to start doing some new services or something like that. How do you leverage maybe some public cloud to get you to things, some new channels? So one thing I want to discuss is, if my slide will move, is where is your workload going to potentially fit? I'm going to talk about private cloud, I'm going to talk about public cloud, and I'm going to talk about hybrid cloud. A lot of people are thinking, okay, where does my workload fit? I need to do these new video services. What type of service is it going to be? If it's going to be, typically, if it's going to be a 24/7 channel, typically we're seeing customers run those in private cloud. And I say typically because there are some exceptions to that. We do have some customers running 24/7 operations in 100% public cloud. Typically, those are customers that have no infrastructure at all. They don't have any video history, and they, if you are have no infrastructure, how do you get that infrastructure to get your services up and going? Some of the hybrid capabilities we've seen is people that have their existing infrastructure and they want to burst or scale into the cloud past what they are able to see. And typically, private cloud implementations are more geared towards the capital expenses. And with public cloud, Robin touched on it earlier if you were in his last session, but they're typically OpEx models, but not only operational expenses are you going to be doing per month, but you need to be able to optimize those expenses, because just going to the cloud doesn't automatically mean you're going to save money, because you need to do it right in a well-architected solution, and you do need to make sure that you find services and practices that is going to keep you within budgets. So the good thing about Ateme is Ateme is a software vendor, and we have to service both our customers that have private cloud or on-premise type solutions. We also have to service public cloud solutions, and we also sometimes or have to fit those hybrid solutions. And there's a couple tools that can help us with that. So I want to talk about microservices. So microservices is one way to try to split up applications so you can use them in different, you want to split up your different functions. So if you have one particular failure or one particular software upgrade, you can just change a particular piece. If anyone did computer science or computer engineering that's an attendee on here, you're sitting in school, your professor was like, do it in a function. Your C or C++ code may have been a million lines long, but you had functions to do your particular items. So splitting up applications into functional areas helps to make those particular functions work really, really well. And so you can have microservices without something I'm going to mention here is called Docker. Docker is a way to containerize applications in a microservices. you can basically create containers around your microservices. So I want to talk about why containers in Docker are good from an efficiency standpoint. And we're going to talk a little bit about how that may look like in a typical infrastructure. So the good thing about our company is we've been working for the past several years on moving all of our applications to containers. And what is a container? Actually, before I do this, I'm going to do a poll right here that I really wanted to do. I want to find out here if, oh no, let's see. I want to find out who on here is using I'm gonna launch a poll here that basically asks, what does your infrastructure look like today? I'm interested to know if the people on this call have a 100% on-premise solution today, if it's 100% on cloud, if you're kind of doing maybe a mix. If you're doing a mix, are you more towards the, are you heavier on the cloud side, or are you heavier on the on-premise side? So it looks like we got quite a few on-premise. It's heavier on the on-premise side. Let's see if I can, we got a few more coming in. That's okay if everyone doesn't vote. I'll keep this open for just a few more seconds. Yeah, so out of the people that did vote, we are heavier, and let's see if, I'll share these results just so everyone can see on this call. It's interesting to see, so out of the 12, 80% are on-prem, 4 people here are on-prem, 100% on-prem. So 8 out of the people on this call are typically on-prem, which is 100% fine. But what does an application look like when you are on an on-prem physical server? You have an app, it runs on a server. If the server fails, you have to replace that server. It's something you can touch. It's something that you can see probably. One of the problems though with physical servers, there's limited resource sharing. There's not a lot of elasticity when you need to scale your application. It's kind of fixed. And when there's redundancy, you have to have something externally managing that redundancy. So a lot of people have been like, I need more machines. I need more machines. I want to split those resources. So 20 years ago or so, maybe, VMware came out. And VMware allowed you to run many machines on top of a single machine, so you could basically share your resources better, which is quite good. And it was used heavily by the industry, but it's got a little bit of efficiency problems because you're going to have like a base OS. You have a hypervisor that basically talks between the hardware and the virtual machines themselves. And there's a scheduler basically that has to allow CPU resources for the machines. And what you have is you have multiple operating systems in your VM infrastructure, which you don't necessarily need. So your application is really far from the actual operating system that's running on your host. So Google and some other companies have been working and part of their cloud platforms to create containers. And Docker is one of these applications that allows all containers to share the exact same operating system, to be closer to the if you can share the operating system, you can basically run more efficiently. It's one single operating system. The other thing about containers is they're very small. You can make a container of only the applications you need. You don't need a whole virtual machine with an OS and a web server, for example. You can just have an application of just a web server, let's say, running as an application on a host, which means all applications share the same operating system, and you don't have to worry about some of those efficiencies. Well, these microservices really help. They help a lot because you only have to change the pieces you want, but how do you orchestrate it? If you do have a web app sitting on one of these things, how are we gonna manage that? So how do we manage containers? Well, the good news is there's something called Kubernetes, which again is a Google, project that they have made public. And the good thing is it is standard in the industry for IT and now for video like Ateme. We are making sure we leverage IT technology to get the same type of benefits that the IT industry is getting. It allows us to manage applications much easier. You need this orchestration piece to tell you things like, where's my container going to start? If I have an application or container fail, how do I replace that container? You don't want to have, programmers writing things to automate things automatically. They already have an orchestration tool written for this. And all of the common companies for public clouds, GCP, Azure, AWS, as well as the private companies, the VMwares, OpenShift, Kubernetes, there are projects available for people that have their on-prem data centers to take use of Docker and containerized applications, which is much more efficient than the VMware. So I will say that in 2 hours, if you are or aren't familiar with Kubernetes, if you're not that familiar, we do have a 1-hour session over Kubernetes orchestration. I highly recommend anybody that is new to Kubernetes or may not know what Docker is or may not know what Kubernetes is to visit our session on this. But we're going to go real quick over a couple slides on what a hardware versus a cluster, a Kubernetes cluster looks like. So let's say you're in your data center today, you have multiple servers, and this is a database example. You're going to have multiple databases on every single server. While in a Kubernetes cluster, you can have your database spread across the cluster. You don't really exactly need to know where it lives. You know it's in the cluster. You know it's got certain requirements to be able to run. And thanks to Kubernetes, if one of these databases fails, it will know how to replicate it from the other two. I try it sometimes for people that are not familiar with Kubernetes to explain the high availability similar to RAID. Many people know RAID 5, for example. You usually have a couple drives and a parity. You need two to make. You need two good ones to basically check the other one to make sure it's okay. And it can relaunch that and rebuild that in another node wherever that may be needed in your data center. So about Ateme and how we're moving to microservices. Historically, if you have appliances, hardware, you have a hardware appliance encoder, you have a hardware appliance IRD, you have a firmware file. This firmware file historically would flash the FPGA, it would flash the system code to reprogram chips on it. So it could boot and run new code and have a nice day. With our Kubernetes microservice applications, it's a little bit different. We have a public registry. So all of our developers are contributing to this public registry for our customers. And our software updates are always going there. And then what a customer is going to do is they're going to pull our Ateme software modules. We use a combination of Helm and Charts to basically get our application loaded. You're going to pull that into your local registry. Some customers that are on-prem may not have internet access, and that's 100% okay. You can do offline delivery over a USB or a hard drive. You're going to have to pull it from a computer that's got it, get it into your network, and pull that into your local registry. If you're using Amazon or Google, you can use Amazon's ECR, Elastic Container Registry, put that in your own registry. And then what you can do is you can deploy that into, you can use something like CloudFormation, for example, to spin up a test cluster, test it, make sure it's working, or you can spin up in parallel with a production. And then you can spin down your test cluster and go to production with that software. And as I said before, Kubernetes, the orchestration layer, also allows software rollbacks really easy. So let's say you do get to deployment, whether it's in cloud and Amazon with EKS, or if it's on-prem with Kubernetes, rollbacks are really, really easy. And you don't have to worry about appliances. If you have 10, 100, thousands of servers, it's really easy to roll that back in with an orchestration layer. If you were also part of the previous slide of the previous presentation by Robin, we talked about that Ateme's really not offering products anymore. We want to build a solution because we have customers from broadcasters, service providers, sports production, and we have a wide variety of customers that have a wide variety of needs. And instead of trying to shoehorn customers into little holes, we're saying, hey, we're gonna have a module. Customer A may need something different than customer B. So what can we do? We can help build you the custom solution that you need for your workflow, whether you need SDI or not. Maybe you need some HLS packaging, some CMAF packaging. We're going to do our CMAF demo here soon. We also have, we also make sure that we partner with you, right? You're not just a customer, you're our partner, right? So we want to make sure, one, that we give you local Ateme support. We have DevOps in-house that will help you get your deployment running if you need help with the on-prem or cloud deployments. We're gonna help you take care of installation and help you with your day-to-day operations. We're heavily involved in all of our support and deployment. And yeah, any type of solution you need, Ateme has it, all microservice-based, all Kubernetes-based for just about any type of workflow. I'm gonna start this demo soon. What time is it? 6:21. So also wanted to say, why would you choose Ateme? Ateme, again, as if you did in previous slides, Ateme owns all of our own intellectual property for our codecs. We are not paying vendors for codecs, so we lead in the VQ market. We're world-class video quality for MPEG-2, not just standard MPEG-2, high efficiency MPEG-2. AVC, again, it's a software codec, so the more, and it's a 100% pure CPU software codec. We do not rely on hardware chips, ASICs to do our encoding. So as new codecs are available, and as we have CPU available, we can do that easily. MPEG-2, AVC, HEVC, AV1. We have an elastic transcoder encoder capability, which means the more CPU we have, the more we try to use that to make sure that you have the best possible video quality. We have solutions for 4K, 8K, and all of our I/O in our systems. We've got SDI, IP, UDP, RTP, FEC, the traditional broadcast protocols. We've got SMPTE 2022-6 uncompressed SDI over IP. We've got all of the redundant SMPTE 2022-7 protocols. If you need seamless IP redundant switching, SMPTE 2110 for video, audio, data. We have ad insertion capabilities. So we can integrate with third-party ad servers, external ESAM POIS servers we can integrate with. We can take care of any type of packaging you need. We can take care of HDR pass-through. We can do SDR to HDR up conversion. So any type of video you need, if you need to say to your viewers, hey, I want to give them HDR, you're not producing your content in HDR. We have PhD staff members that are working on these HDR lookup tables, making sure that they are fitting, and they're trying to make sure that your content looks pristine. And it's hardware agnostic. If you need it on-prem, no problem. We'll come get it on-prem. If you need it in the cloud, no problem. We can do that as well. We have some customers running on VMs. We have some running in our containers. And some customers don't use containers at all. They have a software installed directly on a unit. So I'm gonna talk about, this is if you were a content provider, you need to get your, or maybe you're a distributor, you need to get your content distributed out to people. This is a sample kind of playing off of our earlier primary distribution. And maybe if you want to do something in the cloud, you need a well-architected solution. One, it needs to be geo-redundant, right? So if this was Amazon, you can have different availability zones, which are in different geographical locations, or in the different regions, then you will have a different AZ. So the regions are geographical redundant, but within the availability zone, then it's in the same area of the country. We have a gateway product, basically, that you can do ARQ input and output with, or you can use something like Media Connect if you are in Amazon. But if you're in Azure or Google, then you need gateway basically to get in and out of the cloud. We've had sessions on our playout system. Our playout system can do file playback or live inputs, but we can also take live inputs directly into the cloud. So we have some customers doing live input directly into our Titan solution, transcoding for HLS stacks to feed like OTT, or you can take live feeds directly in the cloud. We can do a stat mux with that and feed that back to on-prem, or that can be your satellite alternative, saying I can deliver you a feed over satellite, or I can deliver you a feed over IP. My distribution, like StatMux, is ready to pull out of the cloud, whether it's directly to a satellite modulator or whether it's directly to your end affiliate, whether it's Zixi, SRT, RIST, Media Connect. So let's take a look at a simple linear demo. I'm a little bit long, so I do have a, what I'm going to show is, instead of speeding through a demo, I'm going to show, we have an AMS running in the cloud. I'm going to show you what our monitoring system looks like. We've got a few services running. This is all running on our France Amazon account. By the way, I did not set this one up. We usually do everything here in North America when we're doing North America content. And they have some sample sports content to show some StatMux and HLS. Now, I did earlier today this morning. I made a video of this just in case I ran out of internet. And it's exactly 5 minutes long. So I'm going to show you what our AMS looks like, because our AMS, this will help me on the time, but you can view your cluster information about your Kubernetes clusters. You can do your user management. You can look at all your instances in the cloud. You can view alarms of what's going on, active alarms and alarm history, and you can see information about your services. So really quickly, I'm going to show you what our clusters look like. We have a little Titan file cluster. You can see some CPU usage if you want to see some disk area. We also have some Kubernetes pods running in the background if you want to see information about the pods. And our AMS web app that we're running is also a Kubernetes microservice container. And you can see the exact same pods and like cluster information of what your management system is running on. Exactly like we showed the high avail 3 databases running, you can run 3 nodes of your AMS to have a highly available management system. The particular demo I showed before, we have a couple instances running. We have a Titan Live instance and a Titan Mux instance. Obviously, you can have hundreds or thousands of instances in this, but it allows you to filter if you want to view them. You can export and load configurations to all those instances as you need. And you can also set up redundancy groups in our AMS if you need to do like unit redundancy. The other thing we have is services. If you want to be able to see all of your services from one single pane of glass, one user interface, doesn't matter where your services live, you can see all of your thumbnails in one interface. You can delete, stop, restart, add text overlays. If you can do blackouts for your services here. And let's say you want to edit a service, you can click on the instance that it's running on, load up its web interface. Jing did a great Titan Live web interface intro earlier today too. But let's say you want to look at one of the inputs and probe your input. You can check to make sure you've got the right codec or right resolution. Yeah, okay, that input looks good. You can also set your outputs. We can do multi-packaging in our lab, but these are the StatMux pools, and you do get the same controls in our live web interface as our AMS web interface. We have the same thing with the MUX. You can see what services are mapped in the MUX, and you can kind of click on our MUX web interface if you want to go see some information about that. I'm not going to go through a whole input output setting up everything from scratch, but I did want to show you at least the what the StatMux pool looks like. Let me check time. You can see all your services running. Our StatMux pool we've discussed earlier as well, but basically we're checking scene complexity based upon the resolution, based upon the content type. We adjust bit rates accordingly. If you need to like mass update all your units, let's say you want to do some blackouts or logo insertion, you can create configurations and you can blast that out to all your units. And at the end, I'll show you a brief way how you can schedule those too. Then we have alarms. We didn't have any active alarms at the time I made this, but if you want to look at alarm history, you can look for specific units, or you can filter for specific services. So if you have thousands of services or hundreds of services, you need to be able to find the units or find the services, and you can kind of track history of how a specific service may have been behaving. So this is just some sample of our alarm view. And then we've got a little bit of our schedule. So I don't have anything scheduled here but all of these like mass updates, blackouts, logos on, you can create schedules for certain things to happen. You can schedule for your services on service X at, on a specific date at a specific time. You can get that done. So I'm going to move on to the CMAF. I'm going to do I didn't record the CMAF demo. I tried today, but it was only doing one page. And because of this demo, I really want everyone on this call to be able to see the real time and the real latency. It's much better live demo because this is a very interesting one for people that have latency sensitive applications. So why does streaming latency matter? A couple reasons. One is customers have usually dollar signs attached to them. You know, everybody's eyeballs. You know, you want to know where what these eyeballs are watching. They're going to either be watching the broadcast TV, who's watching that, or they're going to be watching some OTT content. And there's some good and bad things for both of those. But for live content, a common complaint of watching live content is, why is my live content so much further behind than the live broadcast? Maybe they want to watch the OTT, HLS type deliveries because it's easier for them. I don't know, maybe they want to watch it in their phone or on their iPad. But so they may get complaints, and if you don't want viewers falling off of your platform, because you want people to be able to watch and maybe do some of that targeted dynamic ad insertion. So this is most important for live auctions, gambling, live sports, esports. Usually it's not as a big deal for other applications. So real quick about CMAF. CMAF is Apple and Microsoft joint kind of specification. We've been working with these companies as well on these standards. Our developers have been working with some of the Apple developers, for example. And the standard is, or the proposal is actually not too old. 2016. 2016 wasn't that long ago. Apple said that they would start supporting the fragmented MP4 later that year. The specification was finalized in 17, and in early 18, the standard was officially published. Even though still today, most people, most OTT broadcasts, the majority of them are still HLS transport stream delivery. And just a few weeks ago, some low latency guidelines were officially published. So we do, there's a couple forums. There's the Dash Industry Forum, there's the CMAF Industry Forum. And both of these forums are making sure that the Dash and the CMAF is going to work together. So I want to talk a little bit about CMAF so we can get to this demo. In a typical HLS delivery, you're going to have a playlist. It's an M3U8 playlist. It's nothing more than a text file that points at some segments. They're all transport stream segments. And that is pretty much the standard way that delivery has been happening for many years. But with the Dash, when the Dash team came about, they were like, well, we're going to do fragmented MP4 like file wrappers. They're going to have a different type of manifest. It's an MPD, it's an XML type of manifest, as opposed to the M3U8, which is it's a text playlist. If you remember MP3s back in the 90s, you could just have a text, literally playlist with pointing to files. There are some tags you can put in there. Well, the CMAF is the combination of the two. Let's use a fragmented MP4 wrapper, one file type, because we want to save CDN costs. You don't want to have a fragmented MP4 segment and a transport stream segment, but we're going to have two manifests. We're going to have our legacy like M3U8 playlist. It's just a text file. It's not very big. And you're going to also have your MPD XML like dash manifest. So, okay, two playlist types, only one content type. It's going to help you save that storage. It's going to be less transferring of content across the internet, and hopefully it's going to ease like deployment capabilities, but everybody has to, you know, be on board, and many vendors of hardware devices, Androids and iPhones and such, are now doing that. So, well, how do we reduce latency? So, in a transport stream, let's say that this is a 10-second chunks. You have to fill a buffer, and a buffer is like a water bucket. And once you fill that water bucket, which could be an origin server, that water then has to be transferred to potentially an edge cache, right? So you have to fill 10 seconds into the first one. Maybe you go to an edge device for the second one, and then you got to transfer it to the end user. And maybe that player's got to also download its 10-second segment, and it can't start playing until the full segment is done. So automatically, you're going to get a 30-second delay on an HLS, like non-chunked encoding delivery. So how can we speed that up? We can still do a 10-second segment, but what we can do it is we can chunk the delivery and start transferring immediately. So out of the encoder. So before, the encoder would not try to transfer this 10 seconds until it was done encoding. Now we can encode a part of it, a chunk, start sending that while we're still encoding the rest. And every 200 milliseconds, we're going to be sending. As soon as it hits that origin, it's going to be start also pulling through its cache server. And as soon as it hits the player, the player is going to start sucking it in. So when we go through this demo, we'll show you a little bit of, I'll show you this. So it's demo time. I'm going to show you 3 ways. Well, I'll focus on one, but we got 3 CDNs we're feeding. This is an on-prem encoder, by the way. We're feeding an Ateme workflow. We're using one of Ateme origin and Ateme CDN. We've got another couple sets going through AWS. We're feeding Media Store origin, and we've got that linked to a CloudFront CDN. We also have a little homegrown Nginx server for origin that we are sending to and also feeding CloudFront. So that's 2 different AWS paths. And we also do have 2 Alibaba paths. I'm going to give you these URLs, but I want to see if I can switch screens here. Let's see. So please hold with me while as I get to all right. So what do we have here? We've got this is the demo that I had going on earlier. I don't know if everyone can see my screen. So Lewis, can you see my screen okay?
No, not anymore.
You cannot see my screen?
Nope.
Oh, okay, hang on.
There
Can you
go.
see my screen? Can you see my screen?
Yep.
Do you see a player and some time clocks ticking?
Yep.
Okay. So what do we have here? We have a couple things going on here, and I'm going to explain them. The first thing that we have here is a time internet website. You can go to this website yourself, time.is. So anybody on this call, if you want, go check your time. One important thing here to check latency, what we're going to do is we're going to check our system clock. We've got a little time code ticker ticking, and then what we've got is we've got an encoder sitting in REN in our R&D department in France, feeding these CDNs. And our Titan Live has logo overlay capability. We've been talking about logo overlay all day today. But one of the logo capabilities is that you can put a $STC $. We can embed timecode and burn timecode in the video before we encode it. And it's burning in the system time. That time should be synchronized with the time. The time should be synchronized, and it should be exactly matching this like time.is time. So I'm going to I'll just close out these other tabs. And I'm going to start this little video. And what this is a let me just try to. We're gonna do this ultra low latency demo first. Let's see if it goes. Maybe I needed to open up my new browser. So my system clock, I think it earlier said I was 0.3. Oh, is it? I think I'm 0.3 seconds off, 300 milliseconds. Okay. But what this little demo player is a specialty low latency dash player, right? So I'm going to talk about dash, and I hope everyone can see this in a little bit. But this the bottom left here of this time code is what our Titan is burning in, 4431, 4433. And it looks like we have here, oh, maybe 4 seconds, 5 seconds delay. So we've got 10-second chunks, and as soon as we get through encoding them, we've got 100 millisecond chunks. As soon as we encode 100 milliseconds, we start transferring that. We're still encoding in the background, but we're outputting that to the origin. And it's up to the player to manage the buffer. So we've got some little sliders up here. One is target latency, and one is a catch-up rate. Basically, what you want in the real world, like obviously you wouldn't give this to a customer and say, hey, just like control a slider. You would want an algorithm to basically lower the buffer as low as possible. It's watching, and it'd be maintaining the buffer level to get as like low as possible. But when the buffers are going up and down, the video has to speed up or slow down to like reach that buffer. So there's this other little slider called maximum catch-up rate, which means the video can play faster or lower to meet the buffer in the player. So as you move these buffers down, what you can see is you can get like really, really low latency. What do we have? We got like 3 seconds, 2 seconds. We've got 2 seconds of latency here. If your buffer gets too low, obviously you can get into an underflow condition, right? So you obviously need to make sure that on the software side that we are managing buffers. Now you can see this URL. I'm going to share this with everybody so they can go play with it with themselves. Let me see if I can.
Let's do that at the end, though. We'll have someone from the attendee list ask the question, and then you can paste the link in the chat for everybody else.
Okay, that works. We do have a couple different links. We have a high quality link that's doing 8 megabits. This is a 6 megabit per second low latency, like single profile, fragmented MP4 CMAF delivery. So I've got, it's getting close to the end of this session. So I'm going to stop sharing this just quickly so we can wrap it up and do any questions. And let me do that real fast. I'm going to show you where we got these latency numbers, and we're going to talk about those latency numbers. Let's see. All right, so are y'all seeing this slide, Louis, of the workflow here?
Yeah, but you're in the presenter view, like we see there.
Oh, okay, yeah. Okay, so let me try this one more time. We're gonna share. I need to share the right thing. And oh well, we'll just share this here. Are you able to see it now?
Yep.
Okay. So the way that these latencies are done, right? I'm about to show you some latency numbers, and then we're going to do a quick Q&A. But in this, we're adding the timestamp onto the encoder. We're feeding it to the origin. It's feeding it to the CDN. As soon as it's requested from the CDN, it is like continually transferred to the device, and we're measuring the differences, sending a transport stream output to an IRD. Obviously, a distribution workflow isn't going to be exactly like that, but we're measuring. There's going to be further latencies added on top of that, because once you catch it somewhere else, you're going to probably be encoding it again past that IRD. So this is like, I would argue that this is faster than broadcast latency, but from an encode to decode, encode to a device, encode to an IRD, latencies are about the same. So let's look at the numbers. Glass to glass with a 100 millisecond low latency chunk, we're seeing 2 to 4 seconds in OTT. It varies depending on the CDN, and we're seeing like 1.5 to 3 seconds on a like professional IRD, which is our DR5000. And that's with a low latency dash player. If you use a traditional dash player like Dash.js or similar, your latencies are going to be a little bit longer, because it's automatically going to have some higher buffers. And a traditional like HLS type stream, you're going to have 12 to 14 seconds. But being able to shave 10 seconds off of your delivery to viewers is massive. So I'm going to end that here as we're running out of time. And I was going to see maybe, Louis, if we should do some Q&A. And then I want to also encourage you to check out some of our new, some of our other sessions coming up ahead of us.
Yep. So we got a couple of questions here from the chat. Let's try to get through all of them. One of the questions that we got originally, I guess, when you were talking about Dockers, was, would you recommend to run video workflows in virtualized environments like VMware or in containers?
Yes, I would, especially for an on-premise or off-premise application. I would not. Would I recommend VMware? I wouldn't recommend VMware particularly because of the efficiencies. But I would recommend running, it's either a 100% Docker like application, or you have, when you talk about VMs, if you're in cloud, everything in the cloud is like virtual machines anyways, right? But your virtual machines are Linux operating systems that happen to have like Docker runtime on them, and you can put them in as part of your cluster. So they're VMs anyways, but from an efficiency standpoint, especially if you're on-prem, I would do bare metal installation with Docker containers on top, and then let your orchestration worry about your resources. And the individual will not have to worry about their individual servers and where their applications may be actually running. I hope that answers that question.
Yep. The next one here, so I guess when you went into the StatMux demo, there was a question about whether the StatMux demo was running in AWS.
It is running in AWS. It is running in AWS. So it is running in AWS. So one thing about that StatMux demo, I will say, and maybe the question is this, is because they had, let's see if I can bring the,
I guess the question is about how do you do multicast communication?
Yeah, if it's about multicast, so currently I would not do multicast for the inputs and the outputs of a MUX. Typically, I would do unicast send and use unicast for your primaries and backups for the inputs. You can do multicast, but when you do it, you have to do it over VPN connectivity. So currently, that's how the demo is set up. We're doing multicast in and out, but we don't have, in the particular demo we showed, we didn't have a gateway getting content. We have some files on a file spooler that is multicasting those, but they've got a little private VPN, so it looks like it's all a local network. But typically for our customers that were running in the cloud, they're using things like Zixi or SRT to be able to get things in. And typically that's a point-to-point type connection and not a multicast.
Yeah. So yeah, so it is multicast, but it is just between the encoder and the StatMux controller.
Yes.
And it is running
yes.
in AWS.
Yes, yes, yes. They're all Docker containers. So we talked about microservices. That particular demo was running what we call macro Docker. It was an instance of a Docker container running the MUX piece of software, but we do have a microservice one as well. I did not set up our microservice Titan solution for this demo.
Okay. The next one here asks, does Ateme support CPICs for multi-DRM solutions?
Yes, yes. Yes, yes. We just added CPICs 2.0 support. So if you need multi-DRM, you have multiple DRM vendors that you need to integrate with. Irdetto, Nagra, if they have a CPICs 2.0 interface, we can definitely do multi-DRM integration with CPICs 2.0.
Okay. And another one here asking for disaster recovery use cases. I guess you mentioned that in your presentation. Do you have to maintain an environment in the public cloud?
No, the good thing about public cloud is things like Amazon, you can use CloudFormation templates, for example, to deploy only when it's needed. So this is one of those questions about the on-prem and the off-prem. With an on-prem disaster recovery, you've got to have those assets available. Those have to be like running. Those have to be available when that is, if there's a disaster in an area, or you have to have physical resources to get that spun up somewhere. The beauty about the cloud is you can have templates of your infrastructure and launch it automatically on an as-needed basis. Obviously, you do want to launch and test to make sure your disaster recovery is testing and working on a scheduled basis. You don't let it sit for 10 years and never like look at it. But that should be part of your standard like QA and your standard processes to make sure that all your backups are functional in case a disaster does happen.
Okay. And I think we got time for one more. So the last question I have here is the low latency demo that you did, is it backward compatible with non-updated players for that?
Yes, 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 yes. So I don't know if you can see this slide on a traditional player. It is backwards compatible with legacy players as well. It's got to be a traditional dash player, right? So if you have, back into my timeline, it wasn't added to iPhones, for example, until like 2017 or 2018. But if you have a older device than that, that doesn't have the official support, it's got to have the fragmented MP4 dash support. But if you do have a dash supported device, a legacy player that's not low latency, it is compatible. Your latencies are just going to be higher than the low latency player we were looking at. And I wanted to go, I do we have one other slide I wanted to see? Maybe not. All right. Oh, I wanted to show the links. So what I'm going to do, this is our link slide. We've got a little demo player. What you can do is you can copy and paste this link directly into a player. And I'm going to, can I paste these in? How do I get this link to the attendees here?
So can somebody from the chat? Yeah, here we go. Somebody just asked the question. So if you look at the Q&A, Bill, you can type
I'm going to type answer.
and then
Okay,
just copy and paste the link. Yeah.
Okay, so I am going to send. Okay, I just sent that link. Can everybody see that link? So that is our ultra low latency from Ateme CDN, and I can share another one as well in this last couple of minutes if y'all want to see it. If anybody attendees, let's look at the CloudFront. How about that? I'll share this one also in the demo. Type answer. Here's a second one. If people want to join themselves, and don't forget you want to go to the time code link too. If you want to go look at the time code on your computer versus that. So I think that's it for us.
Yep, I think we're perfect on time. Our next session is from Yannick on securing content with this CA. So Bill, I think you need to make him a panelist and host so you can take over.
Okay, so I'm gonna stop recording here and then we'll let Yannick take over.
Yep, and thanks Bill for the presentation. It was really good.